We're going to start with lesson 12.2 here. We're going to talk about angle measures on the coordinate plane. It says over here that we have if the measure of an angle is positive, the terminal side is rotated clockwise. So we're going to have this. This is going to be like the initial side. You're going to start off to the right through the x-axis. This will be like 0 degrees, and then we rotate up 90 degrees, 180, 270. And then back to 360, etc. So if we go counterclockwise, that's going to be positive angles, okay? And if we start out to the 0 and we go negative, we go this direction. So please notice coterminal angles. 145 in this direction could have been written as 225 in this direction. You end up with the same terminal side. That's why we call them coterminal. This could have been 240 in this direction. So we're starting off to the right and then we're rotating either positive or negative. So if they want us to draw a 210, and the most important thing we're going to get to in a little bit here is 210 will go around and end right there. That's the terminal side. This is the 210 degree angle. If you were talking a coterminal going the other direction, you have negative 150. But one thing we do want to start paying attention to is how far past this x-axis did I go, and that's 30 degrees. That's going to be called our reference angle, and we'll get to that here in a little bit. Negative 45, we're going to go down 45, and we have 45 degrees going down. That one, if I went this direction, would have been 315. So this is pretty basic in terms of how to find these things. 900 degrees, again, draw an angle in standard position. That's 900 degrees. So you go 90, 180, 270, 360, 450, 540, 630, 720. This is 900, I think, ends up right there. 900 degrees. 180 past the 360. So really a 900, when they talk about doing a 900 as a skateboard trick or something like that, you're basically going around once, twice. It's 2.5 turns. 600, same idea. You can go 600. You can go 360. 540, and then it'll be 60 more. So this 600 degrees could have been the same as 240 degrees. Just depends on how many times you're going to go around the roundabout, so to speak. Find an angle with a positive measure and a negative measure that are coterminal. All you really got to do for 210, yeah, you can draw it up. I'm going to be 30 past. There's my 210. But really, if you add 360, that's like just taking another trip around the roundabout, and you get 570. And then you could take 210 and minus 360, which would be about negative 150, and those would be coterminal. So you could keep adding 360 or subtracting 360, and you're going to keep getting angles that are the same. So 330 plus 360 would be 690 for this one. Minus 360 would be negative 30. Biggest thing we're going to do is talk about radians today. So a radian, what does it mean to be a radian? Well, let's draw a little picture here. Before we get to this stuff, let's talk about what it means to be a radian. If I have a circle and I have a radius of r units, if I take a radius, sounds like a radian, so we're going to go along the edge of the circle, and I'm going to go r units up on the edge of the circle. Okay, so I think it's about that far. And then I draw this, and this is still r. This distance that we turned in here, instead of dealing with that angle in degrees, that's going to be considered 1 radian, because I turned the same distance as 1 radius. Okay? So 1 radian is the angle formed by going 1 radius. So if we thought about something like this, let's say I had a radius of 4 and a radius of 4, and let's say that this distance right here was 10.5. If I went 10.5 units, how many radians did I turn? Well, if 1 radian would be 4, 2 radians would be 8, and then I wanted to go 10, sorry. Got a little ahead of myself. 10. So 4, 4, and then 2 more. So I went 2.5 radians. Okay. Now, where does this 180 degrees and pi radians come into play? Well, if you think about all the way around a circle, all the way around a circle is 2 pi r. That's the circumference of a circle. And if you think about what are we doing here? 2 pi times the radius. 2 pi radiuses. That means all the way around the circle, traveling around the outside of the circle, will be 2 pi radians. So the full turn is 2 pi radians is going to be equal to 360 degrees. And since that's still a little bit awkward, we divide both sides by 2. And when you divide both sides by 2, you get pi radians equals 360 degrees. And if you go back, if you think about, 360, oh my gosh, are you kidding me right now? 180, we've got to divide by 2. So half a circle, 180 degrees, is going to be pi radians. If you go back to that original where I went, this was r, and then this would be another r, and then it would be another r. And if you think about pi radians, that's 3.14 radiuses, and it should kind of make sense. We will work extensively with some conversions. The one you really need to remember is, you need to know this one, and then you need to know this one, and then you'll end up memorizing a few of them on accident, and we'll show you how to convert. But this is what you're going to convert, and you're going to use dimensional analysis in order to do this. Rewrite 30 degrees in radians. Okay, so if you don't realize 180 divided by 6 is 30, what you can do is just set up dimensional analysis. I want to get rid of degrees, and I want to end in radians. In general, we put things in terms of pi. So if I simplify, this is 1, this is 6, this is pi over 6 radians. 30 degrees is pi over 6. And if you think about the idea that 180 degrees divided by 6 is 30, it should be okay. Negative 5 pi over 3. Now we're going to go the other direction. Negative 5 pi over 3. Again, that's in radians. I want to get rid of radians. Dimensional analysis, put it on the bottom. 180 degrees is pi radians. Radians cancel out. Now we just simplify. This is going to be 180 over 3, 60 over 1. Negative 5 pi times 60, negative 300. Okay, negative 300. 45 degrees. 45 degrees. Again, 40, 45. And then I want to get rid of degrees, and I want to go to radians. So my degrees go there. That's how we cancel things out, just like changing inches to feet. And 45 over 180 is 1 over 4, so it's pi over 4 radians. So we just saw a bunch that you'll accidentally commit to memory, and it's these ones. Don't worry about the diagram on the right, but these ones over here are going to be important. And if you think about if 180 is equal to pi radians, divide that by 2. Well, then divide by 2, pi over 2. Divide by 2, pi over 4. Divide by 3, 60. And then you can find everything on here. If you think about pi over 6, 5 pi over 6, pi over 6 is 30. 5 pi over 6, 5 30s, it's 150. So they're going to be very related. So you'll end up, what do you really need to memorize? You really need to know that 360 degrees is 2 pi radians. And then you need to know the conversion. 180 degrees is pi radians. And then you'll end up learning these ones on accident or on purpose. And the rest of them kind of fall into place. Arc length. Arc length, this actually goes back to circumference as well. Arc length is the distance along an arc. This is going to be S. This is going to be the arc length. And there's a great formula. Basically, we are going to do radius times radians, and this has to be, your theta has to be in radians. This doesn't work for degrees. So if you think about all the way around the circle is 2 pi radians, so the circumference of a circle. If I did radius times radians, oh my gosh, it's 2 pi r. So you've been dealing with radians since you first started circumference, probably back in the, I don't know, 5th grade, something like that, when you're first introduced to pi and the relationship between circumference and diameter. So radius times radians. Steering wheel has a monster truck with a radius of 11. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? Well, 4/5 of a full rotation will be 8 pi over 5 radians. So I'm going to do arc length is S equals radius times radians. And then you should actually, whenever you're talking about a distance like this, we wouldn't leave it in terms of pi. We would actually multiply that out. And I got 55.3 inches. 55.3 inches. So radius times radians. That's what you're doing each time. Next one, same thing. Radius is 16 radians. 5/7 of 2 pi. So 5/7 of a full turn. That's going to be 10 pi over 7. Again, we're going to plug that into the calculator. 16 times 10 pi divided by 7, and I get 71.8. So again, radius times radians. That'll get her done for you.